Start recording. Hello, everyone, and welcome to Handmade Hero. The code where I was trying to figure out how to reflexively, since I said the wrong word at first, see if I could rearrange that. The code where we stream a complete game live. Okay, I can't even do it. Forget it. We'll start over again. Welcome to Handmade Hero, the stream where we code a complete game live. Here on Twitch, which showed us some ads earlier. What are you going to do? I guess they have to make money somehow. Hopefully you've paid for some kind of a Twitch Turbo or something like that. Whatever it was that I paid for that made me not see ads. Otherwise, you got some nice ads in there, and what are you going to do about it? That's just the way of the internet. Anyway, today we are going to be working on the entity system now, which will actually sort of be an actual entity system. We've gotten to that point where it's time to sort of make it a real thing. And I went over yesterday my harebrained scheme for how I was going to try that. And you can't stop me. It's my code, and if I want to do something crazy, I'm going to do it. And so that's what's about to happen. So, you know, buckle up and quiet down. So today is day 278, and I am going to be working. So the code base you should start with is day 277 if you want to play along at home with your own very own self. And so on and so forth. So here is where we're at in the code base right now. We have this concept of a simulation region. And this dates way back from when we first started playing around with how we were going to handle infinitely large worlds, effectively. Because I wanted to be able to use floating point values, not doubles, because we still might, at some point, want to do this on a platform that doesn't super support doubles very well, like a Raspberry Pi, which didn't have them. Chances are, maybe we could get away with that. I don't know, because they rev the Raspberry Pi periodically. So, when we finally get to doing something like that, maybe it'd be fine. Who knows? But I wanted to avoid that for two reasons. One, because we don't really know if we'll always have access to fast doubles. And the other one is that I wanted to show how you could think about these sorts of problems in a way that guarantees precision without relying on the CPU to have to save your bacon. Meaning, if you actually want to do all your math in a way that guarantees that it's robust, without having to sacrifice being able to have really, really giant worlds, how might you do that? And so we sort of wanted to look at that because it's a more intricate problem to try and solve. And I'm actually relatively pleased so far with the way that we solved this problem. But I feel like we can take it a lot further now that we're going to start thinking about this part of the actual game code stuff more seriously. I feel like we can take this a little bit further. And it was always sort of something that was in kind of in the back of our minds when we were working on this. I can't remember what it was. Handmade World, I guess, right? So I like that we left these introspection things from that time I did the introspection stream. Anyway. So if you take a look at how our sort of architecture that we built at the beginning just for playing around worked, it's actually kind of very harmonious, I think, now when we want to come back here and finally kind of get everything into what you might call a proper entity simulation architecture. And that is, we sort of have this notion of a world position here, and a world position has these sort of chunk things on it and has an offset inside the chunk. And then we've got these world entity blocks, and these are things that just store a bunch of entities, which ones are in that block. And then we've got this sort of concept of a world, and the world, you can query and say, give me back, this for this region, what are all the chunks that are involved so that I can decompress them, right, blah, blah, blah. And so the way that we worked with our sim entity stuff is we say, okay, let's begin simulation of a region. It will go and it pulls out all of the entities that it sees referenced in there. Now, this was a double sort of indirect system the way that it was working before, and the way that happened, if you recall, is when you look at the world mode. I believe we moved it out to world mode subsequently. When you look at the world mode, we kind of had this idea that there's just this giant table of entities that's all the entities that exist in the world were sitting there, right? And that's fine for what we were doing, but I don't really love that, and it's also kind of stupid. It's like this weird constant that's in there. I mean, it's not fabulous. And so what I want to try and do is something a little more brazen, right? And I want to say, look, what if we just can't ever talk about entities in the absolute sense, other than by their ID, and you can't actually look up necessarily an item by its ID in that way, okay? And this is a little weird. Like I said, there's a lot of really crazy off-the-wall things that I'm doing in this entity system because I can. And, you know, some of them may work, some of them won't work. That's okay. So anyway, here on day 278, what I want to talk about here is, so the way this thing was working is, you know, we have this simulation region, and it had like an apron around it too, and we sort of pulled in all the entities that were related to this region. But it doesn't really matter about that part of it so much. What we really care about is there is some box, and we query that box, and we get all of the entities that were in that box out, right? And what we do is we were sort of saying, well, there's this store, there's this flat array. That's, you know, we were calling the low fidelity entities or whatever. And then what we were doing is using this box as the query region, we were pulling out like whoever the people were who were in there, and we were moving them over into the sim region, right? And the sim region is a smaller set, but with bigger entities in theory. We never really did that part, but that was kind of what we were thinking, right? And so what I want to do, or at least want to try to do until I determine that it's crazy, is I want to just get rid of this entirely. So what I'd like to do is say there is no more low entity storage at all. There is only the sim region. They use the giant sparse entity concept that I introduced yesterday that I'm going to try for entities. That's all there is. That's it. And then what happens is when you go to write out these things, they are stored directly in the world chunks. So if this region is broken up, I mean, who knows how many world chunks are overlapped here, but let's say there's some world chunks overlapped, like this kind of a thing, right? Let's say there are 4 of them or something like this. If we wanted to work it out this way, for example, if there were 4 world chunks, then all of the entities that were in, you know, this region would get stored into this world chunk, actually stored in the world chunk. So instead of it being just in the world entity block, instead of that world block storing indices into the low entity table, we actually just pack the entities and they are written out in there, right? So basically, like, we open up the entity block, we write out all the things into it, we close the entity block, and we're done. That's how we store the entities, right? And then when we want to pull them in again, we open up the entity block, we read them all out, and there we are, okay? This is basically just like a streaming system, right? We stream it in, we modify it, we stream it back out again. And we don't care because of the way that I'll end up writing it in terms of being sort of chunked, right? Because we've already written it that way, right? So imagine this now, instead of being a set of indices, imagine this is just a block of data that's like however big we want a world chunk to be. Let's say 64K or something, right? We just stream out as much as we can, and then when we get to the end, we use another block if we need to, right? So when we stream in, all those blocks are considered freed. When we stream out, we pull those blocks back in and overwrite whatever was in there with the new state of the entities. So it's basically just this cyclical streaming system, and basically you just stream in that window. You constantly stream entities in and out as you kind of go through. And also, obviously, this is pretty much completely compatible with if you had wanted to be out of core for some reason. So if you wanted to, for some reason, have it so that this stuff was so huge it can't even fit in system memory, which is absurd because I don't even want to know how long it would take you an infinite amount of time to ever play that game. Right, that's just crazy. But if you for some reason did, you could imagine this being the primitive, because now, all right, if you run on a storage, you just say, okay, entity blocks just get flushed to disk now, and we load them back in when we need to. Problem solved, right? So, you know, we could, if we wanted to, make this out of core at that point, and it would be totally workable. And maybe someday we will, just so we can say that we did, because we're stupid and ridiculous. All right. So that's the way I want the system to work. And so the first thing that I'm going to do is I'm going to try obliterating the low entity array entirely. And see if I can get away with that, how many things that I will have that will be problematic, right? And you can already think of one thing that's problematic, right? And that is when we have the entities that reference each other. So for example, in the current system, we might have, this is a real example, right, that we already have in the system. We have the head and the body of the hero because they can be disaggregated if we want them to be. They point to each other, right? They've each got sort of a notion of, hey, I've got like a pointer to either of you. But we already know that those get converted to pointers during sim and converted back to indices when we end, right? So we already know that there's a translation that happens there. The head stores the low entity index of the body stores the low entity index of the head, so that they can know which one and think about where each other are, ask questions about each other. What I'm going to do is I'm just going to replace that with a hash in the sim region. So what will happen is as the entities are streamed out, right, or rather streamed into the sim region, their unique IDs, which will just stick, that can just be some random 32-bit number that we monotonically increment, their unique IDs will be in their entities as they get unpacked. That unique ID will go into the hash table, right? And when somebody else is looking for that ID, when they're unpacked, they will get it out, right? Now, there's a little bit of a nastiness there, which is this is kind of have to be done in 2 passes, because until you've unpacked everything, you don't actually know what all the IDs are that you might want, right? And that's a little inefficient, and it's kind of unfortunate. But we can do ourselves one better if we want to and make it so that it actually isn't inefficient at all. And the way that we can do that is, since we are going to be writing these things out, what we could choose to do first is we know all of the entities that are going to get packed into a region. So if we wanted to make packing take a little bit more thinking, we could make packing pack the indices into a separate part of that stream out buffer. So for example, when we stream things out to a world chunk, we could put all the indices first and then all of the data, right? We could do that. Now, I don't know if that would put too much of an onerous weight onto our streaming system, because now we have to do 2 passes over the writing portion, right? And I don't know if that's a bad thing or not. It's really hard to say. What we could do, potentially, is keep things sorted by chunk or something like that, but I just don't know. It's just a little bit dicey. So what I'm going to do at the outset is I'm not going to do either of those things. I'm just going to say there's 2 passes. So there's the unpack pass and the pointer fix-up pass, right? I'm going to just have that be the way that it works. And we'll see how bad it is, and then if it's too bad, we'll try to figure out something smarter as we go. Okay? And that's the idea. Here we go. This is going to be a lot of edits. I don't know that they'll finish today. Probably they won't. So this will probably be a today tomorrow thing to sort of get this code organization sort of a little bit more robust, if you will. The first thing I'm going to do, I'm going to try to take this in steps. You've seen us do this very many times on Handmade Hero, and I'm going to do it again, which is that I don't want to break everything in the architecture at once, because again, even when you've done tons and tons and tons of architecture work, like I have, your brain is simply not really a computer, right? And there's things that you'll forget, and there's things that you can't predict. So when you are working on things, you always have to sort of treat it as an experiment. Don't assume that the thing that you're doing is right. You have to go, well, I think it's going to be right, but I need to sort of experiment and make sure. And so I'm going to take it one step at a time and make sure that my assumptions don't appear to be completely invalid at any given stage before I get too far down there, right? So the first thing I'm going to do, I'm taking a world entity block, and I'm just going to make it a fixed size. So I'm going to have some data at the end of it that I could have used or written. So let's say that I want that sort of data block to be, or just we'll just call this entity data or whatever here. Let's see that that entity data block that I want to read and write is going to be 64K, like I said, right? So I basically want to have 64K of bytes, right, in this data block, and that is what I will use to like stream in and out, right? And then instead of an entity count, the entity count is not going to be involved here in any way. Instead, what I'm going to have, well, actually, you know what? I probably would still keep it, right? To be honest, I probably would keep an entity count. So the entity count would probably still be there because that might aid in allocation. If I can grab the world entity blocks out and figure out what the entity count is first, like it might, well, I mean, when we unpack these things, I guess is all I'm thinking. Nah, you know what? It's not going to be there. The entity count we probably don't need. So I'm just going to say we don't have the entity count. So we probably won't have the entity count. What we'll have instead is just how much data there is, right? So we'll just say like entity data size. And that's just how much of the 64K do we actually use. Now, obviously, we don't actually need 32 bits to say how much of 64K we used, but It doesn't really matter, because in this case, this is the majority of the data. This is not that interesting. So we're going to have something like this, and that's going to pack our any data. All I'm going to do now is compile the program and see if it explodes, right? Like, I don't really know, because I don't remember exactly how those things are being processed. I think they were allocated on demand, so I wouldn't expect anything to really explode here, but let's double check, right? So there you go. Already we did explode specifically, because when we create worlds, we were having some kind of a size problem here. So what's happening? What's the complaint? Let's see. Default arena param size init. Who is allocating this? The world struct. Why am I out of space for my world struct? Is that just because there were chunks? And you can see exactly why I put that in there, right? It was to find specifically that thing. So let's take a look quickly at what that actually is. Where am I looking here? Okay, so that is, I'm doing a push struct of the create world. Ah! That's because the chunk hash does not operate on pointers. It's just a static set of 4,096 of those. That's... So I don't know that I want that to be true anymore. I mean, maybe we do, because, hey, whatever that amount is, we would keep it allocated, I guess, at that time, but... yeah... How do I want to deal with that? I'm not really sure, because this is basically going to take, I mean, this is the majority of our memory, but we don't want to, if nothing is sitting in that hash slot, we don't want to use up space for it, right? So that just seems like probably not such a useful idea in general. So I'm thinking more like we probably want to make this so that when there's nothing in the hash slot, it's just empty. And that seems like probably a better idea to me. So I feel like we would want to do something like this probably, and only have them be replaced there. Yeah, I feel like that's probably better. That's just my assumption. So yeah, so what that would basically mean is we'd grab it out here, and this would be changed to a while chunk situation. And to be honest, that's a cleaner loop anyway. I mean, I know why we did it originally, because we didn't want there to be any sort of weirdness there. Oops. We wanted to like be more cache friendly, so we didn't have to sort of doubly indirect. But I'm not too worried about the moment, because our lookups generally only happen that one time when we pull things out of it. So I'm not sure that we really care too much about that. So I'm going to go ahead and put this in here where we where we'll loop through our chunks in that fashion. And let's see what else we got. So it looks like we should just do result. And in here we'll say result equals chunk and result equals chunk. Right? I think that's what we're looking for. And let's see here. Well, in this case, if the arena is non-null, we allocate. So we do have a slight problem, which is that if we run out of chunks, we want to allocate an additional chunk, right? So what we probably want to do here is get rid of this concept of chunk uninitialized, because we don't need that anymore, right? And kind of, we can actually clean this up quite a bit. That was all written because of the way we wanted to do that sort of initial bit there. And so the tile chunk uninitialized is probably okay to just delete at this point. So if I run through my chunks and I don't find anything in the hash table that matches it, right? This is the match criteria here. So if I don't find anything, then that is just this code now. This code only runs under that circumstance, right? In fact, what we could say is, well, I'll leave it like this for now. And so then in here we'll say, well, okay, if there's an arena, right, and I didn't find a result, so I'm want to always insert this because they pass an arena and there isn't actually one that I've located. Then what I want to do is I want to create one of these, right? So the one that I'm going to return, is this new world chunk that I've created. And then what I want to do is I just want to make sure that it gets pushed onto the hash table in the correct location, right? So the chunk hash here at this hash slot, I want that, whatever is in that hash slot, I'm going to make that be my next pointer. So I'm going to like keep it around, like so. But then what I'm going to do is say, well, now that first thing in the hash slot is me. So it's just a singly linked list that I'm sort of pushing things onto as they get added to the hash, right? And then I don't care about this anymore. So that created, what I actually needed. But I also need to initialize the other data in it here because it, obviously that's not initialized. So let's put that in there. And I believe that will clear it to 0, which I don't want it to do, right? Because it's a lot of memory, and I don't want that memory to be cleared to 0 if it doesn't have to be. So what I want to do here is go in and say, well, all right, whatever the world chunk stuff is, I'm sorry, not whatever the world chunk stuff is. Handmade, let's see, handmade.h. Whatever the push struct does, I want to pass the flag at the end of this, right? That says, hey, don't clear this memory. So I'm just going to say, like, don't clear it when it comes back to me, because I'm going to do the clearing myself. So then when I have that, I need to go ahead and specify in my result here that the rest of this stuff is actually okay. So let's see here. Let's see, world entity block first block, that's fine. And we've got the chunk XYZ the next in hash, that's all initialized. So all I really have to do here is say, well, that first block there, that block needs to be initialized. So the first block entity count has to be 0. The first block entity data size has to be 0. And the first block next has to be 0. But I feel like that's stuff that we should have been doing before, in a sense, in some kind of a centralized initialization phase. So I feel like there should be something that does, let's just take a look. So we don't actually have that anywhere, oddly enough. So I'm going to say, just for now, because I feel like this should be a thing that's concrete, I'm going to say that there's a clear world entity block, right? So that basically I don't have to remember, what it takes to initialize one of these, because it's not clear to 0. Clear to 0 is very convenient, because then anyone can just clear to 0 and you're done. When I start wanting to actually have an initializer, then you're into more constructory land, where you're like, I want to know that this thing is getting created in a specific way. So I just want to make a place where that can happen clearly, right? So when I'm doing this world entity block clear, I know that the entity count has to be set to 0. Again, that will probably go away. I know that the next pointer has to be set to 0, and I know that the entity data size has to be set to 0. But everything else can be uninitialized, which is what I want. So here I'll just change this to be clear world entity block, and I'll change that to be saying that whatever that first block is, that's a thing that has got to go. Now, tile chunk uninitialized, again, in here, this is sort of a separate thing that's talking about these world positions. These world positions are going to go, but since the tile chunk uninitialized thing, I guess I should probably leave it in here, tile chunk initialized, just temporarily, because this is a separate part of the code that we'll also be getting rid of. I don't want to get rid of it yet. So we'll say that the null position and the isval stuff, tile chunk initialized, that's going to be whatever it was before, int32 max or whatever. So that's fine. Okay. So let's see. World chunk next is not a member of world chunk. It's not? I thought we just said that it was. Next in hash, sorry. There we go. There's our chunk return. That's actually called result now. And here are our x's. Okay, so what's this? In create world, this initializes this. Well, this doesn't have to be initialized anymore. It's just 0 now, so we don't care about any of this stuff. Right, that's just totally fine. So that doesn't matter. Now this world arena with the parent arena stuff, I don't really remember what happens when we do subarena, whether the subarena gets cleared or not, but I'm going to see, does it? Yeah, so I don't actually want to clear that anymore either. Oops. All right, so now I want to actually run. Let's see what happens here. So there's our standard stuff. We're basically totally fine. So good deal. Everyone's happy. Everyone is smiling. All right. So now that we've got that under control, and I know that I can put a bunch of data into those chunks, the next step now is getting rid of, I think, the sword, because I don't really, that's a separate sort of thing that existed in a null space. I have other ways that I'll probably think about and deal with those later. And so I'm going to just go ahead and get rid of those now, because I don't even really want to consider those, because they're really not necessary for this stage of the development. So what I'm going to do is I'm going to take out the sword situation entirely. So inside sim region, where we had this entity, and it had this concept of the sword thing in here. Where was it? Sword. Sword is going to go away. Goodbye, sword. And now all of the things that were sword related are also going to go away. Those are just gone. So goodbye. Oops. Goodbye. And this sort of creation of the sword, this add sword nonsense, this is all going away. Because of course our hero doesn't have a sword anyway. That was just an example we used a long time ago. All right, so I'm going to search for sword in general and just excise it at the moment from the code base. See what we've got here. There's a sword collision. And I don't know if we've got any more uses of the word sword. We've got this concept of D-sword. D-sword can stay because we're actually using that. We just probably want to rename it to something other than D-sword at some point. So here is this nonsense here. That's all going to go away. Goodbye. And off we go. All right. So now we're still running okay. At least it would appear. Our little new shrunken fat hero is there, and we're all good. So now I'm going to flip back and actually do the thing I was talking about with the low entities. So here's that table of low entities where they're all stored in this array. And so what I want to do now is move them out of that array and into the other system. So the first thing I'm going to do is I'm just going to take that low entity. I'm literally just going to put the entities into those chunks just verbatim. And that's going to take a lot of doing, right? Because I have to modify it in both the sim region and the creation stuff that we're actually doing in sort of the world mode, if that makes sense. So let's go ahead and delete that for the moment. And now we've got like a total, we've got a total disaster on our hands that we're going to have to fix. But that's fine. That's what we wanted. So now let's see what's going on here, and sort of clean everything up. So the first thing that we need is in our sim region, right, when we're doing our simulation, we need that hash table that remaps things. And in fact, I guess now that I think about it, we already have that hash for mapping ourselves when we sort of move things around. Not when we move things, to map things in the simulation set, we already sort of have this hash here. So I'm assuming that we actually use that. Let's see if that's actually true. Yeah, so we have get entity by storage index, right? And we're actually already doing that. So we already have our hash function working, which is pretty great. So we don't even have to do that. It's like we already sort of did a little bit of that work for us, which is pretty great. I'll be honest, it's been so long, I don't remember why we really needed that. I guess because sim entities and low entities technically weren't the same thing. So I guess it's just because I was always thinking I was going to do this, because I guess that's why we even did the copy, because otherwise we could have avoided the copy. All right, so hey, past me, thank you for doing some extra work for future me. That was nice of you. Very nice of you. So anyway, here we are at Ludendi Reference, and this is obviously the place that's going to take a reference to an entity and convert it, to something that is a direct pointer to one of the sim entities. So what we have to do now is we have to go ahead and make sure that this works properly. Now the main change that we're going to make here is these loads used to pull almost like pulling a piece of string and unraveling a sweater, right? What we used to do here is if we didn't find the entity, we would go get it out of low entity storage. But from now on, we don't want to do that anymore. The rule is if you don't find the entity in the region, then your pointer gets nulled, right? That's actually what's supposed to happen. So our entity references are now going to be things which basically say, you have a reference to an entity, it tells you uniquely what the entity's ID is, so if it is within your simulation region, you can see it and access it. But if it is not, you can't. Make sense? I hope it does. Anyway, so here we are in Ludendi Reference. So the big change here is that we're not going to do this pull. There's not going to be any pull. What's going to happen instead is we're just going to have the sim entity hash gets out of the hash what this index would correspond to, and then it tries to gank the pointer out of that. Now, if the entry is null, then we simply will set it to null, and there just won't be any pointer set. Okay? And that's it. So that makes that easy. It also means we don't have to pre-declare add entity anymore because this can't force the entity to be added. Now here we are in our giant loop where these things kind of get pulled out. And you can see here in the block we're pulling out the low entity index. So really all we have to do now is we just have to go ahead and say, well, instead of keeping entity indices, let's just store the actual entities in here, right? Because we have the low entity structure there, and what we can do is just say that that big data array is just going to keep those low entities in it, right? And now I don't really remember exactly how big a low entity is, but it's pretty big, unfortunately, right? And you can kind of see here if it's going to have a sim entity in it because we haven't done any of the packing stuff. You can see that this struct, I mean, I don't know how big it is, but it looks like it's probably something that's, I don't know. You know, that's probably a good you know, that's probably a good 512 bytes or something there. You know, that's big. That's a big one. I don't know how big some of these are, but that's pretty sizable, right? So you figure we can only keep about 100 to 200 of those in a chunk right now, maybe less, because again, we're not doing anything smart with them, and we kind of haven't gotten to that point yet. So I don't know if this will work exactly. As is, we'll see if we hit an assertion, but the first thing I'm going to do is not even try to think about expanding or compressing blocks at all on write-out probably. I'm just going to go ahead and assume that we only use the first world block. And then I'm going to go ahead and upgrade it so that when we're doing write-outs, if we need to, we'll blow it out. Now the read code doesn't have to change. The read code's the same either way, so that's all fine. But the write code, you know, we'll have to introduce sort of a recycle list there, and that's going to be something that we want to think about a little bit more. So here's our code. We say how many entities there are in the block. Again, we probably won't specify that. Eventually, we'll unpack in a more direct fashion, but for now, that can totally stay. And so when we do low entity index here and do this block low index thing, we can get rid of that. The low entity index is no longer a thing, right? Low entity index is not going to be there. And so what we can do is say, all right, and we don't care about this non-spatial thing either until we actually load the thing. In fact, what was happening here? We're grabbing out the low entity this way. Where are we putting it? It looks like we're passing it in here, and we're calling this add entity bit. Let me go look at that first. I want to take a little bit of a look at that add entity call and see what that's doing. So add entity is basically saying, well, okay, if I was able to add one, then test it, I guess. Set it whether it's updatable based on its situation here, and that's fine. But let's take a look at that add entity raw. What's that doing? So add entity raw is looking to see whether this entity, I guess we're just looking to place it in the hash at the appropriate location. That's what it looks like to me. Yeah. That looks like it. So I think we might change the way this works a little bit, right? I'm going to kind of keep it this way just so that things don't get too wonky, but we're going to probably change all of this, actually, to be a little bit more serious. All right. So what I'm going to do here is I guess I'll keep this working the way that it was by basically, I'm just going to cast, right, to the low entity star. I'm going to cast that data block that's inside, this system, right? The data block there. I'm going to take that, what did I call it? Entity data, I think. I'm going to take that and assume it's an array of low entities and just get the entity index off of it, right? By looking exactly in the entity. In fact, this now is an actual entity index, not an index. It's actually the index inside the entity struct, right? So I'm going to get that out, and then I'm going to just continue as is, right? So we're going to use that data directly. Let's go ahead and in fact, you know what? This doesn't have to be here at all, right? That's gone. So it's really just that, and that pulls out that low entity pointer. And so the low entity index here, I don't really know what that's used for, because what we want is that storage index, which is going to have to be something that's inside the low entity as an actual thing, right? Let's take a look here. Inside sim region. This storage index is actually the thing that we want. And so I'm just going to pass that and use that everywhere for whose index is whose, right? So we're just going to pass that this way, if that makes sense. But that's going to probably go away a little bit in a second here. Oops, and I didn't want low. I just want sim. Okay. So now we come in here. Let's see where we're at. We've got low entities is not a member of game rule. You're right, it isn't. And so this stored bit here is not actually the way we want to do this. What we want to do is repack these entities into those world blocks, right? Now, fortunately for me, I can super double plus extra cheat in here a little bit, I suppose. Well, no, I guess I can't. So I've got to actually do this for real, because when things move around, they're going to change where their locations are. I guess if I don't move anything, then it would be okay. So I could, in theory, try to run without doing this code first and just see what breaks, which would basically be something like this. Right? You see what I'm saying here? Hopefully that makes some sense. Yeah. Yeah, and in fact, you know what? There's going to be I'm really liking this so far. I'm thinking of all these nice things that are going to happen. I think eventually. Maybe that's only my wishful thinking, but anyway. So point being, when we add stuff, as is the case here, what we have to do now is we have to start when we, because that's the sim region stuff, and it's, like we said, we got to kind of do some more passes over it. But here out in the regular game code, when we're actually adding things, now what we have to do is make sure we actually add them to basically, we have to add them to the actual physical location where they exist, if that makes sense. So what we want to do here is say, okay, let's create a low entity. Instead of doing it this way, what we want to do instead is basically create a low entity and then pack it into its actual position location, right? That's how we actually want this code to work. And so we want some way of getting a low entity description, like an actual unpack. Well, I mean, I guess I should say is I'm assuming that's how I want to do it. Technically, I suppose if we want to create an entity, we could just stream out exactly the right compressed bytes to create that entity, which might be good as well. But I kind of feel like we might want to just go through one path for packing everything at first. It seems like a better idea to me, just, the brain-wise, I'm thinking that simplifies things a little bit. I don't know. That's my assumption, if that makes sense. So what I want to do here is I don't really want this to work the way that it's working at all. So in here where we do add low entity, you can see that we kind of do that in a bunch of places here where we kind of have this sort of cascading thing. What I want to do is I want to change these to a thing which basically does like a begin and end entity creation. So you begin entity creation, you do some work on the entity that you're trying to create, and then you end entity creation and it packs it, right? That's what I actually want to have happen here. So what I'm going to do is I'm going to change this to be more like, begin low entity, and it passes back one of these or whatever, and then there's an end low entity. Something like this. And this will be like a low entity or entity creation or something like this, right? That's what I think I actually want to do. Now this is going to be full banana cakes at the moment because probably the way, we could do this on the stack or something. I don't know. There's ways we could do this full banana cakes wise. I guess I won't do it full banana cakes at the moment. Instead, what I'll do is I'll still do something that's actually not super great, but it's not the best for threading basically. But I just don't know what our speed profile is going to be like, and I don't know whether we'll have multiple threads adding things yet or any of that stuff. So for right now, since it's wrapped and I can change it to something else in the future, I'm just going to say that in here we have the concept of a low entity, and this is just the creation buffer. Okay? And what happens is anytime you go to create one of these things, the result here is going to be such that you get a pointer back up to that creation buffer. Right? And I can even put a little thing in here that's like creation buffer locked if I want to catch bugs. Okay. So in here, I've got this concept of that lock. And so what I'm going to do is I'm going to assert that when I come here to use the creation buffer, I'm going to assert that that creation buffer is not locked, right? Nobody else has it. And then when I finish, I'm going to assert that it is locked. And that way I can just tell that, no two people are using this at once, because right now I haven't designed it to support that concept. And so if in the future I forget what I was doing and I do that, I want to have an assertion that comes up and lets me know, hey, that is not what you're supposed to do. So I'm going to assert that that creation buffer is locked. I'm going to create one of these entity creation results, and I'm going to go ahead and assume that we've got sort of this, this storage index concept here that says where these folks are. Now, previously we did this sort of low index thing. I don't think that's necessary because our sim region has storage index in it. And to be honest with you, if you look at what happens here, it's a world position P and a sim entity sim thing. And I don't really know to what extent we need to worry about that anymore, because we're not really doing, again, like I said, we're going to be doing a compression step. So at the moment, this world chunk, old chunk thing, we could just pack this stuff in there and stop thinking about low entities at all, right? There would only be sim entities, or rather I should say there'd only be entity. There's no concept of anything else. It would just be entity, right? And so we could rename this from sim entity to just entity if we wanted to, because there is no other type of entity. There's just a sim entity and a packed, version that it isn't a struct, so you couldn't access it anyway, right? So what I might do here is just say, forget about all that, right? Let's just forget about this whole concept here where we pass the lowness or any of that stuff. We don't care about that at all, because really all we have is just the low entity, right? That's all that there actually is. And so in some sense I could say, well, this entity creation thing, that doesn't really even need to be a block lock like that. I could just make it so that we pass back a pointer to the low entity. And then when we're done with it, when we're finished with that low entity thing, then then it'll compress, right? Here. And so all we need to do to change this to having only one entity is eventually we'll change these from begin low entity to actually just begin entity, and we'll strip all that out, we'll move the world location in, and it'll be beautiful and wonderful. All right. So assuming that this is what we're doing, where we do the low entity here, we do our assertion that our creation buffer is not locked. We then take the lock on the creation buffer, and again, this is purely for debugging. Doesn't do anything else. It's just for debugging. Then we come in here and say, all right, let's go ahead and get one of these low entities by taking the creation buffer as the temporary place where it's going to go. Right? And here's the result. There you go. We don't care about any of this stuff at all. This is no longer relevant. And so in here, in our sim storage index, we're going to do that sort of entity. We now need that sort of concept of a storage ID that's unique, right? And there are some things that we have to worry about here that we're going to have to reckon with at some point. And I'm not exactly sure how we want to handle them. We'll see when we get to a place where they're a little bit more relevant. But basically, if we create new entities and destroy old entities, we will eventually run out of unique IDs, right? After 4 billion will run out in wrap, and that would be bad, right? So here there's a U32 that's like the next available storage index. And we could make this a 64-bit identifier if we wanted to, and then it never would. But we might want to think about how we're going to do this exactly and sort of upgrade that in the future. So I'm going to put it to do here as well. Worry about this wrapping free list for IDs, where we might actually try to recycle free IDs, and so that this is not just a thing that monotonically increases, if that makes sense. All right. So here we go with my begin low entity situation. I'm going to go in here and say that, my result sim storage index is going to be whatever this next available storage index is. And maybe I'll call this next available entity storage index. And I want that to be 1. So if there have never been any initialized, or I guess I should say, instead of that, I'll say like last used entity storage index. And that way clear to 0 will initialize it properly. And I just increment it before storing it, right? So there's its storage index. And that leaves 0 as a whole so that people can use 0 to say I'm not referencing any entity, right? So we don't need this anymore. If we want to clear this thing, we would have to do a 0 struct on it. So there it is. And I'm going to do a to-do here. Worry about this taking a while once the entities are large, sparse clear. And then we've got this stuff that sets up the basics. So we don't need entity low anymore, really, because just result. But I'll call it that for now, just to avoid changing that code, since we're going to change it all anyway. So there's my entity low stuff. This stuff can all sort of stay the same, right? Temporarily. But we're gonna have to obviously, well, you know what? No, really, that is gonna go down here. So anyway, here we go. So we set all this stuff up. The entity position P, that is gonna go in here. The add low entity result goes away. And, oh, hey, look, do we need a begin end paradigm for entities so that they can be brought into the main high set and then added as, yeah, great. Hey, guess what? All to-dos eventually get done even if you don't remember the to-dos because, hey, it's like you were going to do that. That's why you put a to-do in there. It's kind of funny. Anyway, so here's end low entity. This is going to take the entity that's getting ended, obviously. And what it needs to do is it needs to actually pack the entity into the correct world chunk, right? Into wherever that needs to be. So I'm just going to introduce a function here called pack entity into chunk. And that's going to take the entity and compress it down at the location where it currently exists. Now, obviously, since these are stored in there, that location P is stored in there, I don't really need to pass any of this stuff anymore, and I certainly don't need to pass the entity index because there is no such thing. The storage index is used for hash lookups, but it's not necessary for anybody else. So here's the pack entity into chunk code, and we've got this entity low here. So I'm going to go ahead and just leave it like that, and say that this is a new function that's going to happen. Okay. Deleting low entities at the moment is not something that's ever going to exist here. That's not a thing anymore. The reason for that is you can imagine right now how this is going to happen. If we always do a stream where we load in, op, and then stream out for every sim cycle, all we'll do is just don't stream out anyone who got deleted. So we don't need a deletion strategy anymore. We just don't stream them out anymore. They come in and then, oops, they never get streamed out. So there'll just be a marker that's like this entity got killed or removed and then doesn't get streamed out anymore. Okay. Let's see, entity low. Not much time left, unfortunately. Let's see, end low entity is going to have to take the world mode, obviously, like so. And entity low. Oh, nice. There we go. So pack entity into chunk we need to write, and for the moment I'll just internal it here, right? But I won't actually implement it. Do we have a not implemented? I don't even remember if we ever made one of those. So pack entity into chunk. I don't know what that's going to take. Probably just the world, I'm thinking. Oops, and it's already got that. Probably just the world and the entity. So we don't have a not implemented, huh? Too bad. I often define a macro that's like not implemented, which just asserts. It's like if you got to this code, you're sad because nobody wrote it. So missing semicolon before identifier add grounded entity, that is true. So this is just going to be exactly the same thing, essentially. It's just a pass-through that does a little bit of extra work. There we go. And world mode type P, add low entity is begin low entity. Begin low entity. Oops. And add grounded entity, or I should say is now begin grounded entity, right? Because I don't know, is there any such thing as add grounded entity that isn't called from inside somebody who edits the entity, right? I'm assuming the answer is no, but I don't really know. And it's not, so that's good. So this is really begin grounded entity. And off we go. And I'm just going to call this end entity, actually, for now. Okay. So there's our return of the entity. Oops. Which is wrong because it needed a pointer. Here is where we start to actually use this stuff. So here we have to do a low entity entity. We're just going to do begin grounded entity on it. And then we're going to do end entity, and that'll be it. Right? We're going to come through here and add wall. So now when you do something like add wall, we really, if you're, the only thing that you can do with these when they get returned, and I'm going to look to see what anyone does do with them. I'm going to see if anyone needs stuff back. So for now, when you add stuff, I'm not going to return anything, but we could return the storage index if we wanted to, right? But I'm going to get rid of those temporarily for the ones we don't care about, right? Because I can, because I will, and we'll worry about that later. So here we've added, you know, the entity, and we wanted to add flags to it. So then what I'm going to do is just end it here. And now we've added that wall, exactly as before. Add grounded entity, in this case, is been changed to begin grounded entity. And let's see, low is undeclared identifier. That's true, because it's entity. Add low entity result, again. I think I've got a few minutes left, because I started like 5 minutes late or so, if I remember correctly. So I'm going to go right up till the end. And again, this is really just mechanical edits here, right? I mean, you can see what I'm doing. It's not mysterious. I'm just doing the things that I need to do to kind of maneuver this into place. Let's see. Okay, so add player. I don't really know. That might require some degree of, yeah, you can see that it wants to know that information. So this is going to have to take an entity index back. And so what I'm going to do here is, one of the problems I think that we had before, sort of, that we just didn't know about, is we really want that index to not be a bare index. We want people to be able to see that this is basically like an entity ID, right? And I just want to wrap that up so that people know that it's a special thing. You can't do anything with it. You can't add to it. You can't modify the value. It gets created at creation time and it's never touched. So I'm going to make that be a specific thing at the moment, right? And so I want that to be very explicit, right? So what I'm going to say is that, all right, we've got this entity ID. Oops, and that's not good. We've got this entity ID, and the entity ID is going to be the thing that's used here for this, like the storage index, right? And I'll probably change storage index to be named ID later, but again, there's so many edits in flight right now, I don't want to add any more other than the basic ones that we have. So, yeah, so the storage index, for example, is, you know, anywhere that we were using it, it's not a big deal. It can just be changed to something very straightforward. Where is storage index? So like something like this, like these will all just be entity IDs that get passed through, right? Get hash from storage index. Let's see here. Right? And we'll clean this code up when we have time, but again, we're sort of, like I said, you know, with an hour, it's always real hard to do the big edits like this, but you got to do them. They're very important, so you know, you don't want to not. All right. Oops. There we go. Entity reference index. So that also, so the concept of an entity reference, wherever that ended up being, should also be an entity ID. There we go. Only 2 minutes left. We're not going to be able to make it to there. All right. Let's see here. Ludendi reference. Okay. Storage index is an entity ID entry index. So an entry index here, in our case, should probably also be, where's the hash? Right there. This should also be an entity ID. All right. So yeah. There we go. And add entity raw is still taking one of these, so let's get rid of that. Entity ID. These can be done on value as well. And yeah. I don't know about these. These we can probably, yeah, these are probably not even, collision rules will probably clean up as well, but anyway. So there we go. All right, so now we're back to normal, and that's all fine. So inside here, what I'm going to say is I'm going to return an entity ID, right? And there's my add player code, so I come in through here and I add all this stuff. Now I have to do a couple things just to change this to working in the simpler way that we've created now, where you just get back the pointer. Here we go. But I also then have to sort of do the return properly here. So when we come through and set up this code, and it's all happy and fine, when we set up the camera following code and all this other sort of stuff, I have to now have some notion of what these storages were, right? So what I want to do now is say like, oh yeah, that's my storage index, right? And same here. And my storage index has already been set. So then when I do end entity here, right, and I do end entity body and end entity head, now I can't access that anymore. So before I go, I have to do like a result equals whichever one I was returning. I guess is the body is the one I'm returning. No, but the head is really the player. So I think it's the head that I'm supposed to return, really, right? I would think. So anyway, so because the head's what we move around. So I'm going to do head sim storage index. And I guess these have to be sim as well. It'll be nice to get rid of that sim thing. We won't have to do that anymore soon, too. This is going to be so nice. I'm looking forward to this. Anyway. All right, so these are all begin calls, and then we've got our end calls there, and that's all fine. That can go away. And what is the problem? Following entity index. So this this camera following entity index thing, that really in the world mode should be an entity ID now, because anywhere that we were storing an index should be actually using an entity ID, like so. And eventually we might want to have a is valid for that, but I think 0 is fine. It doesn't really matter because we're never going to change that aspect of it, certainly. Okay, so there's our situation. We'll put our result in there. I think Monstar probably doesn't have to return anything in particular, so we should be able to basically treat this as a straightforward conversion. There's our entity and our end entity, world mode entity. And the same is true for our familiar. And entity, and delete all of that. So that's, yeah, that's about right. Hello, entity, oops. There we go. And these, of course, are begins. And okay. So let's see where we're at now. Add low entity. Obviously, that's true that there is no entity, but we don't have to do this anymore because we don't need to reserve a slot. So that's gone because there is no such thing as a slot. We come in here. We've got our entity index. When that comes out, it can go right into here. Our con hero struct, our controlled hero, that's in Handmade, right? So let's see, controlled hero, there it is. This should really be an entity ID. And so we can change this around. All right. When we do a delete low entity on this, we're going to have to do a to-do on this, right? Because this is not implemented yet. I'm going to leave that in there for a second. Let's see what else we got. Entity debug IDs. Game world mode. Clear collision rules for entity storage. So yeah, so those collision rule stuff we have to upgrade slightly. We're mostly there though. There's really not much else left here. This could be a value, certainly. There's really not that much left. Let's recompile this. So we've got delete low entity. We haven't done that yet. We've got this clearing here thing that happens, and that's fine. We've got low entities. This debug ID thing, I don't know how we'll really get around that. We want the debug ID to be something unique, but we don't have a real way to do it. So I don't know, to do, Casey, we don't really have a way to uniqueify these at the moment. So I have to think about that. In fact, I'm not really sure. Yeah, I'm not sure what we would do here. Do we have a debug just uint ID? I mean, I guess if I did this, I could just say, well, okay, it's a void star. Let's see, cannot convert from, there we go. These are just straight ahead comparisons, so that's good. Clear collision rules for, probably just needs to take one of these, but eventually that'll be fixed as well. And then low entities, debug pointer ID, again, so that storage thing we don't really have a way to deal with, unfortunately. All right, so really the only thing we have to do here is have a way of marking one of these entities as deleted, right? And we don't quite have a way to do that yet in the sim region stuff. So what we don't want to do is do delete low entity. So I'm just going to put an assertion here. add mark this and delete in sim. But all right, we're at least compiling. So I'm going to call it for today because I have to go early, actually, today. I've got to go in about 4 minutes. So I'm going to call it there. I could maybe take a brief Q&A, but I would say hold off on any lengthy ones because I'll probably post them until tomorrow when we finish with this, if that makes sense. Hello, Milton. Renga, this is more of a meta question, but I found myself placing to-dos in my code at places that I don't want to deal with while I work on something else. However, as we all procrastinate, how come back to the to-dos? So what I do is once I get into like ship mode on something, I have like something like this. Right? Which just prints out where all the to-dos are. And what I do is I go through them all and I assess way at that point in the in the process before I go into like serious ship mode. I assess which ones are actually to-dos I want to do before shipping, which ones are to-dos that I'll maybe do in some future version and maybe it's so be postponed, and which ones are just superfluous now because they don't make any sense with the way the code ended up. And I do that big call, and that's like what helps me generate part of my like shipping list of things I need to do, if that makes sense. RBD jellyfish. What's the highest number of errors you've ever had compiling? Well, it's capped at 100 on most compilers if you don't turn it off. So, like on MSVC, it just won't print past 100. So, Miblo, I arrived too late to the pre-stream to let you know that yesterday's episode hasn't made its way to YouTube. Ugh. Yeah, YouTube's been real bad for uploading lately. It's probably just sitting there like in a weird bad state. I'll take a look at it. All right, so I'm going to go ahead and wrap it up, and tomorrow we'll kind of go through this and finish up because we're in a good state right now. I'm really excited for this. I'm really excited for this entity system. I have to tell you. But anyway, thank you everybody for joining me for this episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can do so by pre-ordering the game at handmadehero.org. There's a little handy dandy button there. And it comes with the source code so you can follow along. We also have a forum site you can go to if you want to ask questions. We have a Patreon page if you want to support the video series, and we have a tweet bot that tweets the schedule if you want to catch the series live. There's also an episode guide for catching up on past episodes. And if you would like to see the exciting conclusion of, well, the first step in our entity system rewrite, that will be tomorrow, and I think it'll be pretty awesome. But it'll continue to get awesome. Basically, the next couple of weeks are going to be pretty awesome, just in a general awesomeness. So prepare for a lot of awesomeness, and if you can't handle awesomeness, I would not recommend tuning back into the stream over the next couple of weeks because it's going to be absurd. That's about it. Until tomorrow, have a good time programming, and I'll see you guys on the internet. Take it easy, everyone.